Okay, so we're going to work through and find the integral of x by sine to the third power of x by cosine to the fourth power of x. Now, just to forewarn you, this is not a very pleasant integral, not because it's particularly hard, but because it can get very tedious and error prone. And as we work through, if you do find or think of any way that I could simplify the process, please let me know in the comments below, as I'm happy to admit I am still learning mathematics as I'm creating these videos for you. Okay, so my approach to evaluating integrals is the first thing I try to do is to simplify the integrand, simplify what is being integrated, and unfortunately I really can't see any way to simplify this any further. So the next step is then to try and simplify through a substitution. And there's no obvious substitution for me either here. And then after that, we resort to our techniques of integration, and the first one is integration by parts. Now the formula or the rule for integration by parts is the integral of u dv is equal to u times v by the integral of v du. So if we have a look at what we're integrating here, effectively we have two functions. We have sort of a polynomial function in the form of x, and we have a trigonometric function in the form of sine cubed of x multiplied by cosine fourth of x, cosine to the fourth power of x, I mean. So in this instance, I'm going to let u, the function u equals x, and dv equals sine cubed of x by cosine to the fourth power of x dx. Okay, so it's important that we copy down the dx part to complete the dv part. So if we take the derivative now of du with respect to x, du dx, that's equal to 1, and I can rearrange the differentials and say that du equals dx. To get v, we integrate dv, so it's the integral of sine cubed of x by cosine to the fourth power of x. Now I'm not going to go through the process of finding this integral because in a previous video we've already solved this integral, and I'll post a link in the description or in the top right hand corner here so you can refer to that one. So I'm going to cheat a little bit and just write the result. So the result of this integral is cosine to the seventh power of x on 7 minus cosine to the fifth power of x on 5. The integral of x by sine cubed of x by cosine to the fourth power of x with respect to x is equal to u times v, so u times v, which is x times the cosine to the seventh power of x on 7 minus cosine to the fifth power of x on 5 minus the integral of v cosine to the seventh power of x on 7 minus cosine to the fifth power of x on 5 du, which is simply dx. Okay, now I have this secondary integral to perform, to evaluate, in order to find the overall integral. So now I'm going to go through my strategy again. And my strategy is, let's look to simplify this integrand first. Let's just write the function out that we're integrating, or the integrand, cosine to the seventh power of x on 7 minus cosine to the fifth power of x on 5. What I'm going to do is factor out a cosine of x. If I factor out a cosine of x, these powers reduce by 1. So I have cos to the sixth of x on 7 minus cos to the fourth of x on 5. And this is the function that we're integrating now. Okay, so what was the point of this manipulation? Well, I am now going to find a substitution. So recall that the Pythagorean identity, cosine squared of x plus sine squared of x, is equal to 1, which means cosine squared of x is equal to 1 minus the sine squared of x. Okay, so now we're going to write this integral as cosine squared of x cubed on 7. Okay, so if I expand this index back into the cosine squared, I get back my cosine to the 6th power. And similarly, we have minus cosine squared of x all squared on 5. And we copy down the cosine of x dx. And now because cosine squared equals 1 minus sine squared, I'm just going to plug these into here. So the integral becomes 1 minus sine squared of x cubed over 7 minus 1 minus sine squared of x all squared on 5 by the cosine of x dx. Okay, I might be making this more complicated, but this is where we start to simplify. So we're going to make a substitution. I'm going to use the letter p, so let's let p equals sine of x. And for the differential, dp dx is equal to cosine of x, which after separating the differentials, dp is equal to cosine of x dx. So this integral becomes the integral of 1 minus u squared cubed on 7 minus 1 minus u squared all squared on 5 du. I'm sorry, we actually use letter p. So let's change that. We got 1 minus p squared cubed on 7 minus 1 minus p squared squared on 5 dp. Okay, so I'm going to make a binomial expansion here. 1 minus p squared squared is equal to 1 minus 2p squared plus p to the power of 4. And then 1 minus p squared cubed is equal to then 1 minus 2p squared plus p to the power of 4 by 1 minus p squared, which equals 1 minus p squared minus 2p squared plus 2p to the 4th plus p to the 4th minus p to the 6th power. And simplifying that, we get 1 minus 3p squared plus 3p squared, 3p to the 4th minus p to the 6th power. So the integral becomes the integral of 1 minus 3p squared plus 3p to the 4th minus p to the power of 6 all over 7 minus 1 minus 2p squared plus p to the 4th all over 5 dp. So now we've just got an integral with powers of p. I'm going to simplify and combine these fractions just to make life a little bit easier. So we have the integral. First of all, we've got a 7th minus 3/7 times p squared plus 3/7 times p to the 4th minus 1/7 times p to the 6 minus 1/5 plus 2/5 times p squared minus 1/5 times p to the 4th dp. Okay, careful when you're expanding this minus into the numerator here. The signs do change around. Okay, so before we integrate, we'll make our final simplification. So we've got the integral. A 7th minus a 5th reduces to negative 2 on 35. Negative 3/7 p squared plus 2/5 p squared reduces to negative 1/35 of u squared. 3/7 times p to the 4th minus 1/5 of p to the 4th is equal to positive 8 on 35 p to the power of 4. And force of habit, I'm using the letter u again. Should be p squared. And finally, the term that remains is negative 1/7 times p to the power of 6 dp. Okay, so as I've said, we've only got now powers of p to integrate. So now we have the result of this integral is negative 2 on 35 times p minus 1 on 35 by p cubed on 3 plus 8 on 35 by p to the 5th power on 5 minus a 7th times p to the 7th power on 7. And now with p equaling sine of x, we back substitute, so we've got negative 2 on 35 of the sine of x minus 1 on 105 times the sine cubed of x plus 8 on 175 times sine to the 5th power of x minus 1 on 49 times sine to the 7th power of x. Okay, so remember this is the result of the integral of the cosine to the 7th power of x on 7 minus cosine to the 5th power of x on 5 dx. Okay, so we can sub this result now into the original integral. So we have the integral of x by sine cubed of x by cosine to the 4th power of x dx is equal to x by cosine to the 7th power of x on 7 minus x by cosine to the 5th power of x on 5 minus negative 2 on 35 by the sine of x minus 1 on 105 by sine cubed of x plus 8 on 175 by sine to the 5th power of x minus 1 on 49 by sine to the 7th power of x. And expanding this negative in, we get positive 2/35 by sine of x plus 1 on 105 by sine cubed of x minus 8 on 175 by sine to the 5th power of x and plus 1 on 49 by sine to the 7th power of x. And because this is an indefinite integral, we never forget the addition of an integration constant plus c. Okay, so that takes care of that integral. But what I'm going to do now is to make a visual confirmation of this result. Alright, so here I am in Desmos Graphing Calculator, and this is a great little utility that you can use to visualize functions. The address is just here. It's a free tool, so go check it out. Okay, so the red curve represents the original function x times the sine cubed of x by cosine to the 4th power of x, and the purple curve is the integral. So what I'm expecting is that the red curve will represent the slope, or be the slope function for the purple curve. And I have confirmation here because we see a rather horizontal line here, and the slope here is 0. So then the purple curve increases, and we get an increase in the slope to a maximum rate of increase, and the increase then starts to slow down until until the purple curve becomes horizontal again, and so the slope becomes 0, and the same pattern repeats again. The purple curve starts to increase, which corresponds to a positive slope, but the rate of increase slows down as we go up here towards a horizontal line where the slope will be 0 again. So this visual here shows me that I did get the correct result for my integral, because I could have quite easily made some minor calculation errors with these coefficients, and you'll see that the curve will change shape if you do get these coefficients incorrect. But anyway, that'll do it for this video. If you have any questions or feedback, please use the comment section below. For now, best of luck with your studies, and I'll see you on the next video.